So for machine learning models, training must be done manually. And whenever data changes, even minutely, that means if the data is changed in very, very small patterns also, ML model has to be fine-tuned again or rebuilt. Whenever there is a small change in data also, minute changes, forget major changes. When there is a major change, you have to completely rebuild your model. Your model performance will fail totally. When there is a minor change also, it happens for some algorithms. Decision tree, okay, tree-based algorithms, minor changes they absorb. But when you're looking at linear regression and other places, if small changes in data, you will have a problem. So, no self-correction, no self-learning, or self-correction or adjustment. In ML models. In machine learning models, there is no concept of self-learning or self-adjustments. This is not true. Whereas when you look at deep learning, so this visualization is what you will understand. See? You can see from this diagram, in machine learning, input is given manually or training. There is a manual training here. Feature extraction has to be done manually. And then you send it through classification model. And then you'll get the output. In deep learning, there is no human intervention. In deep learning, there is no human intervention. The algorithms will learn on their own. The feature engineering, feature extraction, everything is done on their own. And they build model on their own. And they provide the output. So this is the difference between machine learning and deep learning. Deep learning are fully automated, self-learning, self-correcting, self-adjusting, and self-model building algorithms. Self-model building algorithms. So the human intervention has been removed in deep learning models. And you can see here, the model is this is a typical neural network. So in deep learning, the fundamental is a neural network. A neural network looks like this. We have neurons. The blue ones are all called neurons. Hello? Yes? Okay. ఉన్నారు మా పేరెంట్స్ ఉంటారు ఇచ్చేయండి. So, neural networks. These blue ones are the neurons and the connectors, the arrows which pass information from one neuron layer to another neuron layer. So, neural networks use neurons, which are mathematical model of human brain neurons. What the researchers have done is they made the mathematical model of our human brain neurons. Human brain has millions of neurons. They connect with one another, and through these neurons, our brain functions, and through these neurons, we learn. Now, these neurons, human neurons, learn by trial and error. Human neurons learn by trial and error, and based on the output of this trial and error, correction is done. Take for example, when we are young, someday we try to hold a teacup. When we are young children, we come to know that teacups are hot and our hand will burn. That message is implanted in our neurons forever. Will you ever touch a teacup with your fingers again? No, right? So the same process which is mimicked in your neurons have been mathematically. Human beings learn by trial and error. That everything we learn by trial and error. And accordingly, our brain corrects. Accordingly, our brain controls our body to correct. Like learning to drive a bicycle, learning to drive a car. Will you drive a car in the first instance? No, right? It will take 30 days of practice, during which time our brain, we need to adjust, constantly change our patterns. Everything happens in our brain. How we press the clutch, how we break the things, until your brain gets tuned to that. You can never learn it. Same thing for the bikes or anything. Your learning process also, you don't learn everything in one go. Constant phase-wise, stepwise manner. The same thing has been mathematically programmed, and the same thing has been implemented in neural networks. So neural networks learn each layer wise. There will be multiple layers, and each layer will have lots of neurons, and these neurons learn and transform the information to the next layer. The next layer also learns and transform it to the next layer. This learning process, as they learn, they fine-tune themselves. They fine-tune themselves. Now, after this learning process, till they commit mistake, till we commit mistake, then what the algorithms will do? They use this backward propagation process. That means they go back step by step, correcting each layer again and again, and try to predict again. Backward propagation. Again, it's a process of learning only. Backward propagation is learning for self-correction. So this whole thing has been mathematically programmed using is what the fundamental of neural networks is. And these neural networks, if you tune them properly, fine-tune them, if you train them properly, they have one of the highest accuracy rates. They are the fundamental of your AI, self-driving cars, robots, drones, everywhere. This is what is used. neural networks. Human intervention is very, very less. Nothing. Even in drones, not the lower end ones, higher end military drones and all, pilot has to do very limited thing. Everything will be decided by the drone. How to maneuver, how to target. If it is given a target, it is do. You know, self-guided missiles. You just put a target to the missile. That's all. No matter what, you just coordinate the GPS. It will go and hit that GPS point. No matter you launch from anywhere in the world, the GPS system in the missile will take it to that exact point and hit the object in that exact point. So the drone will automatically, or the missile will auto self-guide, correct its path regularly. If it sees any obstructions, it goes down or up based on its tracing. All these decisions are taken by the algorithm itself. Facial recognition on your phones, thumb recognitions, all are based on neural networks. So these neural networks have huge implications in data science. The biggest problem is tuning them, because they involve lot of neurons, lot of mathematical calculations. They require special computing, the CPU-based computing. They need GPUs. Graphical processing units are required. And in some cases, they require completely different hardware. Like in iPhone, there are two chips. One is your core chip. The second is the neural bionic chip. Bionic chip is for neural networks in iPhone. Facial recognition, saving your passwords, your identity protection, generating passwords. You know, very complex passwords are generated in iPhones, which are very hard to crack. We generally give passwords very simple, na? Which we can remember. Here you will get alphanumeric passwords, which you cannot remember at all. Only again you need a device to do that. So those passwords and all, if you, I don't know how many of you worked in companies where you get the password generator also as part of your ID card. Not even Microsoft, Deloitte, everybody, wherever you're working on confidential data, if you are working on confidential data, there will be a pen drive sort of a thing. It's a password generator. No, they give that only. Seems to look like a pen drive, which is there, which has a screen. Every time you log in, a new password will generate. Without that, you cannot log in. And these passwords are generated from where? From the satellites and the servers and the neural networks. They're not generated on this thing. The whole thing goes to a centralized server, a neural network will generate a password, satellites, and then based on that, it will give you the. So they're very complex things. So neural networks are initially used for identity recognition. Now they are being used for self-driving cars. They are using for everything. All self-driving cars or what you call mobility is all based on neural networks. Because they are the best in terms of learning. Because when you are looking at mobility, constant adjustments have to be made, right? The parameters change. So wherever you have parameters changing, neural networks are the only option. Wherever you have constant parameters, constant variables, with very minute changes, machine learning models will. But for a car, every minute the things will change, right? When you're driving a car, for 1 kilometer, you will not have traffic. The next kilometer, you're stuck in traffic. The whole scenario will change. Your variables will change. Right. So that is what happens in mobility. That is why we are still not in a position to close the mobile, to identify the correct solution for the mobility problems. Now, unmanned aerial vehicles, since air, it can do anything, nobody gets harmed. But when you're running an unmanned vehicle on road, the damages are very big, right? So unmanned aerial vehicles are different. There is nothing in, there is no traffic in above. So they can do anything, whatever they want. But when you're looking at unmanned vehicles on roads, they are a different ball. What people are saying, it is not easy because the parameters change. Hello? Yes? Yes, tell me. Yes? No, 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 no. So artificial neural network, ANN. We will look at a simple model. We will also build complex models using Google Colab, using GPUs. Because we can do it on our CPUs, we need GPUs, graphical processing units, and we will use GPUs for that. But basic models you can build on your basic ANN, 2-layer or a 3-layer ANN with 100 neurons, you can build it on your CPU. But beyond that, you have to use GPUs. So a typical artificial neural network will look like this. Okay. So this is your input layer. Input layer means your independent variables. This is your hidden layer. This is where the with 3 neurons. This is where the data processing will be done. This is your output. The input layer, the output layer, and the hidden layer. The hidden layer is where the data will be. Because input is constant, output is constant. You can't change it. Let us say I have a data like this, x1, x2, and a y. 2 independent variables, 1 dependent variable. Let us say I have data like this, 1, 0. It's a classification problem. So we have this set of observations. Let us say we are modeling this set of observations. So x1, x2, and the input is 1, and the output is. Now, the neural network will pass this input to each of the neurons. Every neuron, it will give you. If it has thousands of neurons, the input has to go through thousands of neurons. And similarly, from neurons to output, you have a connection. So this we can call it as an artificial network 231. ANN 231. 231 means 2 input, 3 neurons, 1 layer, hidden layer, 1 output. Now, the first step in this is randomly generate weights in smaller proportions for all the connectors in the model. When I say connectors, I am the arrows. The weights will be generated in smaller proportions. Real-time weights will be 0.01, 0.001, like that it will be there. Because if the data is very large, the weights would be smaller. Right. Typically, the weights would be 0.01, 0.001, multiples of these things. So it depends on the data you have and how you are going to do it. You can define it. Since we are doing a manual calculations, for our model, we will take weights between 0 and 1. Because when you go to 0.01 based calculations, the calculations will become very, very decimal oriented and will get confused. So to avoid that, what we will do is to all our connectors between 0 and 1. So for this, we will use weights in range of 0 to 1. The summation need not be equal to 1. We are just going to use the weights between 0 and 1. Okay. So the weights are very important in neural networks. The larger the data, the smaller the smaller the. Now let us say for first connector, I have given a weight of 0.8, 0.4, 0.3, 0.2, 0.9, 0.5. These are the 6 input connectors. And we have the 3 output connectors. Also, we have to give weight 0.5, 0.9. Now, these weights are generated randomly. You can only define the range. You cannot define the. You can only define the range. Should it be between 0 to 1? Or it should be between 0.00 to 0.01? Like that, you can define the range. But you cannot define the. A random generator will be. Okay. So this is the first step within the neural networks. Random generation of weights for all the connectors in your model. All the connectors. If you have thousands of connectors, all the 1,000 connectors weights have to be generated. Once that step is done, then only the step 2 will. Yeah. Only one method. Step 2. The hidden layer calculations. Hn is equal to input n multiplied by weight n. Input n multiplied by weight n. Input into weight. Now this looks like a regression formula, right? Coefficient into input. Here we are using weight, which is nothing but a coefficient. There we use beta into input, right? Here it is input into weight, similar to regression only. Okay. Now, H1, neuron 1 is 1 into 0.8 plus 1 into 0.2. 1. So what I am doing is I am connecting the first. This is H1. 2 connectors are going to H1, 0.8 and 0.2. Inputs are 1 and 1. 1 into 0.8 plus 1 into 0.2 going to H1. H2, 1 into 0.4, 1 into 0.4, 1 into 0.9. H3, 1 into 0.3, 1 into 0.5. So input into weight. Input into weight is what we are doing. H2 is 1 into 0.4 plus 1 into 0.9 is 1.3. H3 is 1 into 0.5 plus 1 into 0.3, which is 0.8. Now, once this initial calculation is completed, then comes activation functions. They are the biggest thing in neural networks. Activation functions process the data in the neurons. Every neuron must have an activation function. Every neuron must have an activation function. These activation functions are the core. These are the core of your network. Now, typical activation functions which we generally use are So it is already 11 o'clock. Huh? We'll complete this step and we'll take a break, okay? Linear activation function. For multiple linear regression problems, use linear regression function. So one of the popular function is linear, which is f of x is x. X is nothing but the regression equation. Regression equation. Now, for other sigmoid classification, 1 by 1 plus e to the power of minus. What is x here? Regression equation. What is the sigmoid? Logistic regression equation. If you remember, e to the power of z divided by 1 plus e to the power of z. Short form it 1 by 1 plus e to the power of minus. What is that? Regression equation. Right? 1 by 1 plus e to the minus x. So this is for binary. Sigmoid is for what? Binary. Right. Similarly, we also have one other thing which is used in classification, very popular, is hyperbolic tangent. Hyperbolic tangent, also called as ANH, e to the power of x multiplied by e to the power of minus, sorry, we are using the notation x, right? E to the power of x minus, sorry, plus e to the power of minus x, sorry, into, divided by e to the power of x plus e to the power of minus x. Just let me check sigmoid. I didn't get minus, not minus by plus, sorry. E to the power of x minus e to the power of minus x divided by e to the power of x plus e to the power of minus x. X is nothing but regression equation. Hyperbolic tangent. Tangent. Again, binary classification. Binary classification. This is also for classification. Sigmoid is also for classification. Now, the problem was we have this rectified linear unit, also called as limit, which is max of 0, comma x. Now, you get negative values. When you're predicting, you get negatives, right? So if something is negative, it will be assigned a value of, and whatever is positive, it will take it as positive values. Now, in derivative calculus, negative values cause problems. It might lead to infinity problem. Remember, logarithms also go through the same problem. Negatives and log 0 goes to. So hyperbolic and tangent and sigmoid sometimes generate negative values or values which are very close to zero, which create problem in derivative calculus calculations. To avoid this problem, rectified linear units have been developed. Now, the problem which I tell you is, this is again a common interview question if you go for a deep learning interview. Vanishing gradients or exploding gradients problem in neural networks. One of the reasons why neural networks fail is because of this vanishing or exploding gradients. What is this? When the waves become too small, close to zero, or become negative, which hamper the calculations. That is one of the weaknesses of using sigmoid and tangent is if it encounters this vanishing gradients or exploding gradients, the algorithm will get stuck there. Infinity, all the problems will come, it gets hanged, it gets errors, all of the issues will be. To overcome this vanishing or exploding gradient problems, rectified linear units are developed. It outrightly gives, if it is a smaller value or a negative value, it will make it zero. That's all. So if you look at the graph also, see rectified unit 0 to max. Whereas you will get negative values, you will also get very negative values and very small values in hyperbolic tangent. You see the axis is negative, right? This side of the axis is negative. This is the problem in neural networks, particularly in derivative calculus. So to avoid this problem, rectified linear units are developed. Where anything goes to close to zero or negative, it will be immediately made. So default activation functions nowadays in all softwares is zero. And when you're using sigmoid or tangent, be careful if the algorithm is stuck, that means it is going through a exploding or vanishing gradient problem. You have to change the. Okay. So let's break and we'll come and continue. Online guys, you can take your break.